Hey, good morning, everybody. And this morning I'd like to talk about the inverse trigonometric functions. I'm going to look at three examples here. So we're going to look at the inverse sine of negative root 3 over 2, the inverse cosine of root 3 over 2, and the inverse tangent of negative root 3. And I'm also going to check these in our calculator to make sure that we get the right answers. So for the first one, well, before we even really do these, we're going to have to talk about what does the actual inverse trig function mean. So let me give you a quick example. So if, put this on the pen here. So if I have the sine of some angle, let's call that angle x is equal to some value a, right? Then I can just switch these around and then say the inverse sine of that value a is equal to that angle x. You probably should have used a better variable for the angle, but x is an angle and a is the value. So all you're doing is just switching around the value and the angle. And that's all the inverse trig function is really doing. It's just switching around. Because remember, when we set up an equation like this, where this is the angle and this is the value, the inverse trig function just flips around where the value and the angle go. So it's not that difficult, not too difficult. All right. And then the other tricky part of this is, well, you know, if this is the value here, negative root 3 over 2, and we're talking about the sine function, if we look at our unit circle over here, and I'm looking for negative root 3 over 2, and we're talking about sine, which is the y values, look, I've got one over here, and I've also got one over here. So what is it going to be? Is it going to be 5 pi over 3 or is it going to be 4 pi over 3? I don't know which angle to use. And actually, I can add 2 pi to either one of those and give you an infinite number of angles back because there's an infinite number of coterminal angles for each of those. So I've got to use some method of narrowing down my choice of angles that I'm going to use if I just give you a value. And so we do have a general notion of a limited scope of our interval that we use when we talk about inverse trig functions. So let's talk about that. So for sine, we're only going to give values between negative pi over 2 and pi over 2. So if you think about a number line here, it's only going to be between values between negative pi over 2 and pi over 2. So, you know, could be negative pi over 2, could be negative pi over 4, 0, pi over 4, pi over 2, or anything in between. For cosine, it's going to be between 0 and pi. Between 0 and pi, and tangent has the same as the sine. There's between negative pi over 2 and pi over 2. And we'll talk about the other three trig functions. They're all either 0 to pi or negative pi over 2 to pi over 2 as well, but we'll talk about those ones later. All right, so when we give our answers in terms of angles, we should be giving them in these intervals here, depending on whether we're talking about sine, cosine, or tangent. So we need to limit it to these angles. Otherwise, we're going to have multiple angles that fit this criteria here. So that's kind of, we needed to get that out of the way to understand which angles we give when we talk about this. Because right away, when I say what's the inverse sine of negative root 3 over 2, I could just look at my graph over here and I could say, oh, it's either 5 pi over 3 or 4 pi over 3. And yeah, that's not right. Now, but in this case, neither of these are going to be correct. Why? Because neither of these are between pi over 2 and negative pi over 2. Both of these values are bigger than that, and I can see that because, so let's go ahead and take a look why. Because if I go here and I just do pi, oops, wrong button, clear that out, second pi divided by 2. The largest my answer can be, this is, remember, the top of my interval for the inverse sine, is about a 1.57, about 1.6. And the smaller of these two values, 4 pi over 3, 4 pi divided by 3, is 4.2. So that's way over here. We need a value that's in this interval here. So what I'm going to do is I am going to, if I subtract 2 pi from this one here, that's going to bring me back over there. I know that's not going to be right because it has to be on this side of the graph. So I'm going to take this 5 pi over 3 here and subtract 2 pi. And that should bring me over here, and hopefully it'll be between these two values. Remember, this value is like 1.57 and this value is like negative 1.57. So I should have a value that's somewhere between these two values when I put it into decimal form there. So 5 pi over 3, so if I do 5 divided by 3, I'm going to leave the pi out here. And then I just subtract 2, like I'm subtracting 2 pi, but I'm just going to do minus 2. I get that, and now I'm going to hit math, fraction, and that's negative 1/3. So I'm going to put the pi back there, so that's negative pi over 3. So negative pi over 3 is coterminal with 5 pi over 3. I basically just subtracted 2 pi from it. So once again, what did I do? I took the 5 over 3 and subtracted 2 from it, okay? And then I just put the pi back there. So that is negative pi over 3. So my answer is going to be negative pi over 3. Now let's make sure that that is in this interval here. And the way I do that is I'm going to do negative pi divided by 3 and see what decimal that is, and hopefully it should be somewhere between negative 0.57 and positive 0.57, and it sure is. So that looks good. And the last thing I want to actually do is just put in inverse sine of negative root 3 over 2, and I should get this decimal here. So you see the inverse functions are right above the actual functions there. So, and I want to be, it actually doesn't even matter if you are in radians or degrees, I believe, for this one. So inverse sine of, well, actually it does, right? Because it's giving us this answer in, we need to be in radians, right? Okay. All right. So inverse sine, and then we're going to do negative second square root of 3 divided by 2. And there you go. Look at that. That was the answer right there. Now we could have done this in the beginning to get what it was, but that just would have given us that decimal approximation. It wouldn't have told us it was negative pi over 3. Now if you would have known that that was negative pi over 3, you know, hats off to you. You've done enough math and enough times you've done pi over 3 to know that's what that was. But if it's asking for the exact answer, you would have had to go through these steps anyways. All right, so got a lot of that out of the way. Let's look at the next one here. So the next one, remember, cosine's a little bit better because we're looking between 0 and pi. So this one, let me write my little thing down here. So between 0 and pi, so that's really between 0 and 3.14. And this is root 3 over 2. Cosine is the x value, so I'm looking for a root 3 over 2. And that is right, the x value, root 3 over 2 is there. So that's going to be pi over 6. Pi over 6. And it's asking for it in radians and depth. That's my answer, right? And pi over 6 is certainly between 0 and 3.14. Let's just check. Second pi divided by 6. It certainly is. And let's do the inverse cosine. Inverse cosine, oh, wrong one. Inverse cosine of square root of 3 divided by 2. And I should get the exact same number there, which I do. So that was a lot easier than the last one. A lot easier than the last one. That's how you do this one. All right. Now this one is going to be a bit of the trickier one, okay? So bear with me on this one. So we have the inverse tangent of negative root 3. So remember what we said. We said that tangent has to be somewhere between negative pi over 2 to positive pi over 2. So we'll use this one up here. Now, this has a root. Remember, tangent is sine over cosine, or y over x. And it is a negative. So a negative tells me that's going to be in this second or this fourth quadrant down here, right? So we're looking somewhere in the fourth quadrant. And it has the root 3 in it, which tells me it either has to be this angle here or this angle here. So I'm really either looking at negative pi over 3 or this one here, which would be, I'm sorry, negative pi over 6 or negative pi over 3. Those are really the two possible angles that I'm looking at as far as the answer for this one. Now, I have a couple of different ways I could do this. If I knew it was down to these two angles that it could be, and I was doing this, I could just, I might just go here and say, okay, I'm just going to go second inverse tangent, first put it in there and just do negative second square root of 3. And we're going to just see which one it is, because we can put that in there. And we get this thing here. And now I'm just going to check. Is it negative pi over negative second pi over 3? And that's the one. And I would have checked negative pi over 6 as well to see which one matched it. So I already know that this answer is going to be negative pi over 3 because I had limited down to 2 of them. But let's see how we would kind of work it out if we didn't want to just kind of go the easy route. So that's kind of the easy route of it. The little bit harder of the route is, since we know it's one of these two, and we know that tangent is the sine over cosine, what we could also do is kind of write this. So it's either going to be negative 1/2 over the square root of 3 over 2, or it's going to be the negative square root of 3 over 2 over 1/2. And you would check each one of those and you would see which one of those would actually reduce down to negative root 3, because one of those two reduces down to negative root 3 and the other one reduces down to 1 over negative root 3. And it looks like this one here is the one that reduces down to -√3. Why? Because the y value here stays on top, and that has the -√3 on the top. Oops. And on this one here, since the -1/2 goes on top, then this √3 goes on the bottom, and that's why it ends up on bottom. So that's how we know we end up using this angle here. So you can kind of go through all of that, but if you narrow it down to 2 angles and you have a calculator, try both those angles, see which one it matches, and then that is your answer there. So, sometimes it's a little bit better to narrow it down, use a little bit of process elimination, understand what they're asking, and kind of go from there. All right, I hope this helps, guys. If you have any questions, please let me know, and I hope you have a great rest of your week. Thanks.